First things first, let's marry the information that we have over here to the diagram to the best of our ability. So we have S with these coordinates, and then they say T has -6 and 4 as coordinates. M and U lie on the same straight line, so that's a nod to what's happening over there. R has -6 and 12, and V also lie on another straight line. So that's talking about these coordinates that have the parameter A included over there. So RV and SU intersect each other at T. M is the x-intercept, so that's pertinent information if we have a look at it in that way. And then they also tell us that SM is equal to MU. So when we start with our attempt at solving any of these problems over there, we're going to have to incorporate at least those pieces of information, and then that piece of information over there. We are being asked to calculate the gradient of RV, which is that gradient right over there. So we can't use V, so we'll end up using T. M and U lie on the same straight line, and R, T, and V also lie on another straight line. So it's the second bit of information that's very important, RT and V. So the gradient of RT is equal to the gradient of RV, because they happen to be co-linear points. So if you have a look at RT, we'll have that is equal to, well, the difference in y values is 6 minus 4, and then minus 12 minus 6 just so happens to be 2, and then minus 12 plus 6 gives us minus 6, and that's all equal to -1/3 when we simplify it. So that's 2.1 right over there. Let's see, calculate the length of RT. It's just a question of applying our distance formula, so that's just going to be the square root of. If we punch that into a calculator, what we'll get is 2 multiplied by the square root of 10. I think that is simple enough. Now, in order to calculate the value of A, we're going to somehow need to use these coordinates at V in a method that makes sense. Now, luckily, so what we'll do is we will realize that gradient of -1/3 applies to the whole straight line. Remember, we were asked to calculate the gradient of RV in 2.1. So what we are going to say is that the gradient of RV is equal to, well, -1/3, difference in y values, which is A minus 12, taken from there, minus 4, which is T's y coordinate, and then we'll have A plus 2 plus 6, because it's minus 6, of course, and that, of course, is all equal to -1/3 as previously discussed. So let's just simplify everything. We'll have A minus 16 at the top, and then A plus 8 at the bottom. That's all equal to -1/3. If we then go and cross multiply everything, we'll find that we'll have 3A minus 48, all being equal to -8 minus 8. Simplifying that, well, we need to add A to both sides. That gives us 4A, and of course we'll have minus plus 40, plus 48 on both sides. Therefore A is going to equal 10.
A few moments later.
If SM is equal to MU, determine the coordinates of U. That makes M the midpoint over here. And by observation, we can just have a look at everything that's on this line that's relevant to the question. And what am I talking about? Well, in terms of the x coordinates, from S we have moved 4 units to the left, so that's equal to minus 8, which means given that this is the midpoint, we need another 4 units to the left. So minus 8 minus 4 gives us minus 12. This is for you, and this is what I mean by observation. And then of course, with respect to the y coordinates, we have moved 8 units down, which means to get to u is going to require another 8 units, and given that the y coordinate on the x-axis is 0, this is going to be 0 minus 8, which is another minus 8. Well, now that the magic of editing has provided all pertinent information back to us, let's see if we can determine the equation of the line SU, which is from there to here. And of course, all we need is a gradient. So the gradient of SU, well, the difference in y values is 8 minus 1 minus 8, all divided by, well, the difference in x values is going to be minus 4 minus minus 12. Which you get from there, and that's all equal to 16 over 8, which is equal to 2, which is a positive value, and that checks out because, well, we can see we are going upstairs as we move from left to right. This is 2.5 we're working on, of course. Then we sub everything into y is equal to mx plus c. So sub m equals 2, and let's use minus 4 into y is equal to mx plus c. What will that entail? So that's 8 for the y value, our gradient is 2, and our x value is negative 4, and that's of course plus c. That is negative 8, which means in order to get rid of it on the right hand side, it's going to add 8 to both sides, add 8 to both sides. So c will equal 16. Therefore, the equation we are after is y is equal to 2x plus 16. Determine the size of angle UTV. UTV. So they want that angle right over there. Now we cannot obviously get that angle directly, but what we can do is just use a little bit of analytical logic and realize that the angle required is part of a triangle setup that looks like that. So such that, well, if I have that angle and that angle, I can use a very simple grade 9 piece of Euclidean logic, which is the external angle of a triangle is equal to the sum of the two opposite internal angles. So these two are opposite, and they are obviously internal. So how does that help? Well, as we can see, I've used a bit of purple over here, and those two are angles of inclination. So we have the inclination or gradient of SU over there. So the gradient of SU is equal to 2. We also have the inclination of RV. Remember, it's that negative 1/3. So all we'll do is calculate those two angles, and then we'll use that little bit of, as I previously stated, Euclidean logic. So the gradient of SU is equal to 2. Therefore, if we call this angle theta and we call this angle over here alpha, we can move forward. So we'll say that theta is then equal to the inverse of tan applied to the gradient 2, which is just going to equal 63,43 degrees. Now if we do the same thing with alpha, we can say that the gradient of RV is equal to negative 1 over 3. Therefore, the alpha angle we have is equal to, well, the inverse of tan applied to negative 1 over 3. And then we'll just add 180 degrees. That way, that's when we use the negative gradient as is and we don't use a reference angle. What we'll get is a negative angle out of this, which is going to give us this angle over here. Therefore, we just add 180. Technically, I should have gone to the right, or anti-clockwise. I should have gone over to the left. So, inverse tan applied to negative 1/3 gives us this angle, of course. And then all we'll do is go anti-clockwise, which is the adding of 180 degrees. So this all gives us 161,57 degrees. Therefore, angle TUV is equal to, as we stated, alpha minus theta. Why? Because it's the external angle of a triangle. So 161 minus 63.43 will give us 98,140 degrees, which is that angle right over there. Clean up time, clean up time. If TV is equal to 4 times RT, determine the area of triangle TUV. That is TV right over there, and that is RT. So if I have RT, all I have to do is multiply this length by 4, and of course I have RT. RT is 2 times the square root of 10 if we go back in our calculations. Therefore, TV well, that's just going to be 4 times. Well, what is RT's length? 2 times the square root of 10, and that's all 8 multiplied by the square root of 10. So we have that angle over there, and all I'll need is this distance TU, and I'll use the area rule as stated on my formula sheet. So the distance UT, or the length of UT, is just going to equal 6 times the square root of 65 if I take the length insert form. So now let's get to the area of triangle TUV, and that's just going to equal, well, 1/2 of TV multiplied by UT times sine of angle TUV. That's the formulation as it is. Remember, it's just 1/2 of the one side times the other side multiplied by the sine of the included angle. So that gives us the area rule, which is just 1/2 of, well, TV is 8 times the square root of 10, and then UT is equal to 6 times the square root of 65 multiplied by sine of 98,140 degrees. If all that is done perfectly to the nearest whole number, we'll have 168 units squared.